All right, everybody, welcome to Lesson 2 for AutoCAD Design for 3D Printing. Today we're going to learn a couple of more things that stack on top of what we've already learned in Lesson 1. Today we're going to look again at scaling in a little bit different fashion. Then we're going to look at orientation and then exporting your file outside of AutoCAD. And then we're going to jump out of AutoCAD altogether and look into a commonly used slicing software called Cura and look at the user interface and how to use that software to finalize and finish your 3D print. All right, so let's get started. I'm going to go ahead and open up AutoCAD here real quick. And let's talk about scaling real fast. So there are normally two places that you would consider scaling. One is going to be inside AutoCAD and the other one's going to be inside the slicing software. So let's look at scaling inside of AutoCAD. Normally when you draw from scratch, you'll be drawing at whatever dimensions you need to draw in terms of units, whether it's inches or metric system or whatever. But sometimes you're going to need to bring in an image and trace over that image in order to create a duplicate of that object. And so that's what we're going to do right now. Let's bring in some sort of sample image and see what we need to do in order to scale it properly. All right, so let's say that I have a bearing that I wanted to insert into my part. And so I found the bearing online and I want to bring in that bearing and create the proper sized hole that I don't necessarily, let's say that I don't necessarily have the dimensions of that bearing, but I do have some information. So let's give that a try. So I'm just gonna go to some image that I downloaded off the internet here. I'm just gonna drag it onto my work plane and follow the instructions here. So I'll click and then I'll just set whatever scale. It doesn't really matter what scale I set it to, and this can adjust the orientation. So I'm just gonna leave it in its orientation. So you can see that this is just a bearing here. And so I want to capture the outer diameter, say, and the inner diameter of these bearings. So maybe I want to fit this bearing into a part, and then I want to fit some part into the inner diameter of this bearing. So the most important thing you have to do when you bring in an image is to know the size of the part. And so if you're taking a photograph, let's say that I just took this photograph with my phone, and I have to have some unit of measurement in the image so that I can match up to the scale. So this picture has a set of calipers, and you can see that it already has some units here, and this is in millimeters. So I have 0 to 10 millimeters, 20, 30, and so on and so forth. And so we're going to say that this, in the image, this set of calipers is the same size as this bearing here. So what we want to do is we want to trace out our parts, and then we want to scale it to make it to the right size. And so let's go ahead and do that real fast. So I'm going to change my layer line to red just because it'll be easier to see. So I'll just draw a couple of construction lines here. So you can kind of see where my cursor is here at the top of the bearing. I will just be as close as I can. I want to try to put my crosshairs right in the center of a line and click. And I have my ortho mode, as you can see on, so I'm drawing straight down. And again, I will zoom in and I will try to just click in right in the center of the line to get as close as I can. And I'll zoom out, I'll hit escape. And I'll do the same thing for the inner diameter. So I'll type in PL for polyline again, and I'll just do it from the side here. And I will click here and here and escape. All right, so let me draw a couple of circles. Now I may not be exact, but it's pretty close. And so what I want to do is I want to make sure that my object snaps are on for midpoint. So I can click the midpoint of each of these lines. All right, so let's draw a couple of circles now. So I'll type in C for circle, and I will try to snap to there. So there's that point there, and you can see that it's there. So now I can snap to the end. So now I have my inner diameter drawn, and I will hit enter again to draw another circle, and I'll run my cursor along this line until I find the triangle, and you can see it's pretty close to that line. There it is. Now I can click to start the circle, and I'll come all the way out here and let it snap to the end and be done. So as I pan around, you can see that what the circles look like. Now I have this object traced, the outside and the inside traced. So if I'm just going to copy this over, see over copy, and just drag this over here to see it a little bit easier. So if I were to check out the dimensions of this, I'll go to annotate, go to linear. We can see that this is currently set to 10.25 whatever inches on the outer diameter, and I'll do this again, and I'll do the inner one. And this is currently 5 point whatever inches. So this is not what I need. I need it to be whatever this is based off of this size. What I want to do is I want to scale this up or down depending on what my scaling factor is going to be. So the next thing I'll do is I will draw a line on this ruler and scale it from there. So let's take from 0 to 10. I don't have to be perfectly exact, I'll just be kind of close, right? So I drew a line that should be 10 millimeters long based off of this image. But if I copy this over, I don't need to copy this, I'm just moving it over just for visual sake. So if this is supposed to be 10 millimeters, if I do a little adjustment here, or not adjustment, annotation rather, we can see that it's 1.95 inches. Now here's where a little bit of math comes in, and again, hopefully you can put this into your mental tool belt in terms of being able to just recall this, how to do this relatively quickly. Then you should make, this should make your drawings much easier to do in the future. I'll try to put a graphic on the screen, but follow me. We know that this is 1.95 whatever inches. We also know that there are 25.4 millimeters to an inch. And so what I need to do is I need to convert this to millimeters before I can adjust my scaling factor. So if I know that this is 1.95 inches and there are 25.4 millimeters to an inch, I can multiply 25.4 times this to get the number of millimeters in this line. So let's do that. So open up my calculator. 25.4 times 1.954161444. There are 49.635700576 millimeters in this line at the scale. But I need this 49.6 millimeters to be 10 millimeters exactly. So if you'll recall, the mnemonic device of numerator over denominator is the same thing as need over dimension. I need it to be 10 millimeters, and the dimension that I have is 49.6. So I can do 10 over 49.6, which will give me my scale factor. So I'll clear this out and type in 10 divided by, I can open up this memory here and grab this divided by, and I'll just paste that in and enter. And so this is my scale factor now. Unfortunately, AutoCAD doesn't have a paste function, so I can't just copy it and paste it in there, so I'll just have to write it down. All right, so the number is 0.20146789274563646. Reciting all these numbers reminds me of that scene from Star Trek: The Next Generation where Data is impersonating Picard in order to take over the ship.
Enter code.
173467321 Charlie 32789777 Tango 732 Victor 731178888 732476789764376 lock.
Security code intact for all specified inquiries and orders.
So now that I have this scale factor, I can take the entirety of my drawing and scale it to that number. So I can take this whole thing and scale and set my base point, doesn't really matter. And now I can type in my scale factor. 0.20146789274563646. Enter. All right, so now I have scaled it to where it should be. Everything is properly sized. So if I were to look at this line again, and I were to just kind of do a dimension again, now that says 0.3937009. But what does that mean exactly? So if I were to take 25.4 millimeters and multiply it times the scale factor, I should get my 10 millimeters. Let's give it a try. So I'll clear that out. So I'll take 25.4 times 0.393700079. And that's pretty close, 10 point all these different numbers. This is, so if this number is a tenth, that's a hundredth, a thousandth, 10,000th, 100,000th, a millionth, 10 millionth, 100 millionth, 1 billionth. So this is 66 100 millionths of a discrepancy that I have, which is far less than what is usually relevant in terms of machining and design. So we made it pretty close, and I'm perfectly satisfied with that scale. So now I have this object here, which is scaled properly. So that is how you scale your objects. Okay, so next is orientation. So one of the attributes of a model is its orientation. Therefore, it's important to properly position the model before it's exported out of AutoCAD. In other words, try to set what is up and down before you export the file. Now, why is orientation important? The mechanics of 3D printing necessarily means that the layers of an object are parallel with the print bed. Now, that understanding will assist you in deciding the orientation of the object that you're going to print. So what I want to do is create an object and look at it from different orientations on the print bed. So let's create a cube here. So I'll just kind of start off with a rectangle. And I'm going to make this 20 by 20 inches. And I'm going to make this a hollow box with 2-inch thick walls. So I'm going to hit the offset command here and type in 2 inches and be done there. And I'm going to make this, I'm going to extrude this by 15. And so to make this hollow, I'll extrude this just by some weird number, just some larger number. You can kind of see what this looks like in a conceptual. And so what I want to do now is make this hollow, so I'm going to subtract the tall part from the shorter part and leave that hollow hole. So I'll type in subtract this first, and then click on that first, hit enter, and then click on this second, hit enter again, and now I have my hollow object. And this is 20 inches by 20 inches with 2 inches thick, and it's 15 inches tall. So as you can see, based off the view cube, what is top and what is front and so forth. But let's say that I wanted this to be a horizontal hole instead of a vertical hole. So I can change my UCS. I'll just type in UCS and change my X and Y. And so now you can kind of see that this is now my top. So I'll click top. Where's my top there? So we can see what my top looks like now. That's what top is. So let's think about the strength of an object based on its orientation when it's printed. If we look at this object, we can see that this is the top part of the object, and we can see this horizontal hole here. It's kind of hard to demonstrate in AutoCAD what it's going to look like within the individual layers. When we move over into Cura in just a second, it'll be easier to demonstrate. So for now, let's just say that this is our top and these are our sides, and we will move on to the next section. So let's talk about exporting the file. An important concept to understand with 3D printing is file type. Different stages of the process will use different file types. Now for this course, we're going to be using 3 different file types in the process. The first file type is going to be the files that are used inside of AutoCAD. That's going to be basically just a DWG file extension at the end of your file name. There are other types. You can use a DXF file or a DWT, but for this course, we'll probably just end up using the DWG files. Out of AutoCAD, we're going to export an STL file. There are other types of slicer files that you can use, OBJ, 3MF, X3D, but for this course, again, we'll be using STL files. Now, inside of the slicer, we are going to create our settings, and then create a third file type called G-code. And that is the file that the 3D printer itself uses in order to run the print. A G-code contains just very, very basic commands of moving left or right or up or down, fast, slow. It sets the temperature of the nozzle, it sets the temperature of the fans, the speeds of the fans, just all of the possible controls that a 3D printer is capable of. Keep in mind that there are other types of files other than G-code, but those are typically proprietary to specific brands of 3D printers. Okay, so let's export this object as an STL. So here's how you do that. So you go up here to your big A, and you will go down to Export and move over to Other Formats. So when you click that, we will click, name our file, we'll call it Hollow Cube, and hit Save. And this is where you select all of your objects that are going to be a part of that STL. In this case, there's only one part, but you could click a bunch of parts if that's what you had to export. But right now, I'm just going to click that and press Enter. And so now we have exported an STL file that's called Hollow Cube. So let's jump into Cura and pull that file in and see what it looks like. All right, so here we are in the slicing software. There are a lot of different kinds of slicing softwares out there of different quality and capability. We mainly use Cura because it's free and it's compatible with all of our FFF printers. There are other softwares that you can pay for that have other features and capabilities, but this should get you through most of what your printing needs are going to be inside of the Idea Studio. Let's bring in our part now, and I'm going to tell you that there is a quirk that Ultimaker has that you have to take into consideration when you bring STLs out of AutoCAD. All right, so I found my cube and I imported it onto the bed. Now, here's what it looks like. So this is what it looks like sitting on that virtual bed. Now, looking at this virtual print bed here, you can see this blue cube here. This is the print volume, and you can see this is the print bed. And anything inside of this unshaded area is a printable area based off of the print head and the kind of material you're going to use. These shaded areas will change. So, but for now, just keep in mind that I can grab this, if I make sure that I have move selected, I can just click on it and drag it around, and that's where it's going to sit on the print bed. If I move it over to that line, you can see where it's now not a printable object because it encroaches on that line. So just make sure that your part is inside of those shaded areas. All right, and so let me show you a little bit of the user interface. So over here, we have a couple of options. We have move, scale, rotate, mirror. Some of these other options you'll use down the road, but these are good enough now. Just basically these top three are going to be the ones that you're going to use mostly. Let's look at this object here. Let's say that I don't like this orientation. I want to rotate it. If I click on rotate, now I have these three rings that I can rotate in the X, Y, or the Z axes. So let's say that I want to take this. I'm going to go ahead and grab this bar and bring it and rotate it 90 degrees. Now it's laying down to where it's a vertical hole like this. So I'm going to click on the object so I can get this menu back available to me, and I want to look at the size of this object. This is the quirk about Cura. You'll notice that these dimensions match what I brought over from AutoCAD almost. It was 20 in the X, and it was 20 in the Y, and it was 15 in the Z. However, they were inches. What Cura does is it disregards whatever dimension that you had inside of AutoCAD, and it assigns it a millimeter dimension. And so this was 20 inches tall. So this print volume is basically 8.5 by 8.5 by 8.5 inches. And so this box that I brought in should have been huge, but you can see how tiny it is because it assigned it to millimeters. So what you'll normally do when you bring in an AutoCAD, if you drew it in inches, is to scale it so that it matches what you originally intended. In order to change it to my original size, you're going to want to change one of these percentage increases to 2,540. Remember, it's 25.4 millimeters to an inch. And so when you apply that to a percentage adjustment, it's 2,540. So if I change this to 2,540, now it's bringing in my object at the original size. Now, it's not going to print this way, but if you wanted to print something that would fit inside of the bed at its original size, you'll always apply the 2540. So let's go back to 100%, just so that we can be dealing with something that's going to fit on the bed. This is just for demonstration purposes. So this is what the file looks like, right? So we have a couple of different views up here. So we have prepare and preview. So once we slice our part, we're going to let it do its thing. We can get a little bit of information about the part now. This particular part is 52 minutes and it's going to use 3 grams or 0.38 meters length of our material. We also have a preview option. So if I press that, we can see what the part would look like specifically at each layer. So I'm going to zoom in here. You can kind of see these horizontal lines. Bring that in closer. We can see those individual horizontal lines. Now over here to the right, where it says 148, we can see that this part is 148 layers tall. So I can grab this ball here at this bar and drag it up or down and see what each layer looks like. Let me zoom back out. We can see what this part looks like. Now this feature right here is called a brim, and as a matter of fact, I'm going to just turn that off so it'll be easier to demonstrate. That's under build plate adhesion. I'll turn off brim and reslice. So I can go back and forth of the part. We can see what it would look like at its layers, and we can see what the part itself looks like. Here in the slicing software, you're going to prepare the file for actual 3D printing. There are literally hundreds of settings that we can adjust to affect how the part prints. Most slicing software are intuitive about optimal settings based on the printing materials. But let's just talk about a few settings that are available in the slicer that you may want to adjust manually as you decide what your part's going to be used for. The first thing I want to show you are the layers. So when I went into preview, you could see that this cube has a cross section that's exactly perpendicular to the walls here. What does that mean? If I were to go back here and click the part and rotate this, I don't know, just some small amount here, and then reslice the part, you can see that the layers now are a little bit different. Let me unclick so you can see it a little bit better. You can see that the layers are not a full cube. So if I were to press play here, you can see that what that slice would look like. It's not actually goes from end to end because the layer is always laid down parallel to the print bed. And so depending on how I orient the part will determine the angle of these layers. Okay, let me bring in another part to better demonstrate the strength or the weakness of a part depending on how it's printed. So I'm just going to click this and delete it. I'm going to bring in this test rod, and just for grins, I'm going to duplicate this, increase it by 1. I'll bring this over here. I'm going to move it, rotate it, all right, and then now we're going to slice these parts here. All right, so let's go to preview and we can see the difference in these parts. This vertically printed rod, you can see the whole thing is 230 layers. So I'm going to you can see that this vertically printed rod is basically just a series of stacked concentric circles on top of each other, right? And you can kind of see that this one, this laying down one is the layers run the full length of the part. See how that runs. So let's think about applying force to these two rods in the same direction. So let's say that I wanted to apply a force that is going cross-section to this part here. Based off of these layers, it won't take very much force in order to split this because the force is parallel to the layer line. Now, if you look at this part here, if you were to apply the same force to the length of the rod, the force is perpendicular to this layer line. And so it doesn't have a weak point like this one does. So this one's going to be stronger if the force is applied in this direction. Now, if you think about this part here with the forces applied towards the end on these two parts, here, if it's pressed downwards, then there is no real weak point because there's no layer line for it to split. Now, if you were to take this and to apply a force at the end going into it, then it will split at one of these layers. It won't be as strong as this printed part here because it's going to split. Now, it may start as a single split where the force is applied, like here, and then start to run down, kind of like the wood grain on a baseball bat, say. But that's its most likely stress point that it's going to break. So depending on how you're going to use a part is going to determine how you orient your part. Now, real quickly, I just want to go over some of these settings that you're going to want to take into consideration when you run a print. Let's go and look at these. Let me finish going over the user interface here. This monitor button is for when you have a 3D printer connected to the network, then you could look at its progress, but I currently don't have any connected right now, so that's not really for use of anything. Now, over here is where you can toggle to show or hide your print settings. I'm just clicking this area here. And this button down here is where you can toggle back and forth to custom or recommended settings. If you were just wanting to do something really quickly, you can just kind of click on these settings here, and it'll automatically adjust your settings based off of the resolution that you'd like to print. But if you wanted to get a little bit more granular, you can click on custom and have some more options. Typically, this is where you're going to go to adjust your print settings. So let's look at a few of these. All right, so each one of these has a drop down and a little gear for settings. So if we open up the drop down, you can see what's currently available. Now, if I knew I needed to print something with a specific feature, but I don't see it here, I can click on the gear and it'll open it up to that section, and I can check to show all the other things that I wanted to keep, and then it'll appear in my profile settings, my print settings. The layer height is how tall each layer is going to be, or the resolution. So if I wanted to do this in a very rough resolution, I can do 0.36 and hit enter. So when I slice this part, we can see these layer lines are a little bit thicker as opposed to clicking 0.15, let's say. You can see that there are more layer lines. So this part has, at 0.15 quality, has 153 layers, and if I were to do this 0.4 and hit slice, we can see that this part has only 58 layer lines, and it prints a lot faster. Your quality is just the thickness of each layer. So if you're printing out a part just for testing to see if it fits or if it looks right, you can go with a lower quality with a higher layer height, just so you can get a quick idea of what it looks like or feels like in your hand or how it works with another component. And then when you're ready to print your final piece, then you can go with a much higher quality or a lower number here. So let's talk about shell. So when you open this, you can see a lot of different parameters or settings. The most common setting that you're going to use is the wall line count. So let's see what that looks like. I'm going to make this a little bit bigger so that we can notice the difference. So I'm going to take this and make it 500%. See if it will print. Yep. So I'm going to slice this part, and I'll do the same thing for this one. Slice the part and see what that looks like. I have the wall line count currently set to 3. So I'm going to come down here and look at a cross section. The wall is the outer skin. So we can see that there's 1, 2, 3 walls associated with this outer skin here. And of course we have the infill, and we'll get to that. So if I were to change this to 2, then slice it, we can see that it's 2. I could set this to 5, and I think you know where I'm going with this. So when you're running a test, usually a low wall count is pretty good, especially if it's not going to have any mechanical functionality to it. So usually 2 is probably just fine. But again, this is whatever you prefer it to be. And let's look at this part here, down here, with the 2 wall line count. And again, you can see that we have 2 walls on this part here with some infill. All right, so speaking of infill, the next section is infill. So infill is just the density of the part. So 0% density is a completely hollow part, and a 100% density is a completely solid part. So I'll change this to 100, and we'll see what that looks like. So as I slice through this, you can see that each layer is completely filled in, and 0, we'll see what that looks like. And if I were to just hit play, you can better see what that looks like. You can see that it's completely hollow on the inside. Most parts don't need as much infill as you think. A lot of times, anywhere between 5 and 25% is more than enough. Again, it always depends on how you're going to use your part. If it's going to be just used for aesthetic purposes, between 5 and 10, maybe 15% is going to be more than enough. And Cura does have the capability of adjusting the infill at different layer heights. That's a little bit more advanced. We can show you that on another lesson, or you can ask us how to do that later. All right, so I'm not going to go into material at this second. There's another place for material. Speed, that is just how quickly this print head moves around the print bed. Now, depending on the complexity of your part will determine how fast you want this to move around. So something like this has very long and straight lines, so it wouldn't be a problem to set this to a bit higher. And by higher, I'm talking about 85 to 90 millimeters per second. Now, if you had something that's really complex, you might want to bring this down to 35 or 40, or if you have a finicky kind of material, more of like a flexible material or dissolvable material or some exotic sort of material, you may want to slow it down so that it won't get clogged or it won't mess up as it's trying to lay down the layers. So another section that you'll want to look at when you're 3D printing is the support area. Now, supports just means printing a removable structure underneath any given overhang. And so let me demonstrate that. So I'm going to take this part here and I'm going to rotate it a bit like that, and then slice it. I'm actually going to rotate it a bit more and then slice it. Move it over here. Now, let's think about this part being printed just like this. So if we go down here to layer 1, I'm going to zoom in a bit, I'm going to press play, see what layer 1 looks like. Okay, so this is what the first layer of this part looks like. So if I were to go to layer 2 and press play, oh, that is layer 2. Let's go to layer 3. And that's 4, 5, 6, 7, 8, 9, so on and so forth. We can see that this part, although it's not much of an overhang, I'm trying to get to it. It's not much of an overhang from this layer here, from layer 11 to layer 12 here. It could handle that much. But if you think about at layer 1, this entire component, this entire piece here, I'm going to get rid of this here. This entire piece here is touching at that single spot. I hit slice again. And there's no way that that little bit of material is going to support that entire thing. And what we want to do is we want to turn on supports, and we'll reslice it. And now we can see that this little structure here is printing underneath it, so it has something to rest on. So if we go back down here, we can start to see that this lattice work is starting to be printed. Now you can see this is printing all the way across here, even on layer 1, because it's got to build up for this back section all the way towards the end. So it understands how much support needs to be printed and where, based off of the orientation of your part. So as I go up on this, you can see each layer has something to print on. Each one of these layers has something to rest against. Now, a support is a support because it's designed to be spaced like this. It understands that it has to have a gap here. If it printed right up against it, it would fuse with the support and you wouldn't be able to pull it off. So it prints with this little gap here, knowing that it'll be easier for it to pull apart. So as we go up here, we can see that there's supports all the way across. And so now there's enough footing for this to adhere to the bed during its printing process. Now, because it prints with a little gap like that, when this is pulled off the print bed, you'll just be able to remove this triangular support, just snap it right off. Now, there's going to be a little bit of artifact on the surface that may or may not affect the quality or the functionality of your part. If it's mechanical, then if it's just that rod's going to fit into something, you may need to send that down. But if it's just going to be for modeling purposes and it's going to be on the backside, you may not even need to do anything about that. But it's important to understand that supports are necessary sometimes depending on the orientation of your part. The last thing I want to cover is how this is going to stick to the bed. So let's take this part here and rotate it back to perfectly vertical. Now, I'm going to move this closer to the middle. All right, so when I slice this part, and I'm going to come all the way down here, it's going to start to print. You can see that it's going to start with this outer layer and then do another one and then start to fill in the interior section. So that's how the order of the print of that particular layer. And then when we go up to layer 2, it's going to do the same thing, and it's going to keep doing that until we get to the top, right? What's happening here is at the very bottom, when the print head is moving along, I'm going to pause here. This print head is again, it's just a virtual representation of what the print nozzle is going to look like. This print head is moving along the previous layer. Let's go up a couple of layers. Is moving along the previous layer. Now, the previous layer may or may not have some artifacts that you just cannot see inside of the software. So some little pieces of plastic might be sticking up, and the distance between the nozzle and this layer may not exactly be what's represented on the software. So this might actually be pressing up against the previous layer. There might be a larger gap. So the very fact that the print head is moving horizontally across here to lay down each bead of plastic, that motion is giving a horizontal push across, and that is multiplied the higher you get up on the part like this. So that leads me to the last component, which is build plate adhesion. There are several different kinds of options you can choose. As I open this up, you can see we have skirt, brim, and raft. I'm not exactly sure what the point of skirt is. I'll show you what brim does. So if I were to select brim and hit slice, you can see that it now has this base that's been applied, and so that increases the surface area of the part attached to the print bed. So that just helps with holding it down, anchoring it to the print bed. So let's take a look and see what skirt looks like. So this creates a perimeter that's not actually touching the part. So I'm not sure the benefit of what a skirt is. You're welcome to look that up on your own. I'm very much partial to printing with a brim. Finally is raft. If I were to slice this with a raft, what it'll do is create a shelf, a full plastic shelf that this entire part sits on. So the base of this column is no longer touching the build plate, it's actually touching the bottom of this raft. I'm not a big fan of this. Sometimes I use it, but the part sometimes sticks to the raft and it's a little more work to get it separated. So I usually just go with a brim, and that's more than enough for the parts that I'm printing. So that is all we're going to cover today in Lesson 2. Be sure to rewatch this as many times as you need until you feel solid enough to move on to Lesson 3. Thanks for watching, and I will see you over in Lesson 3.